Hi, this is IFAI Talking Textiles, and this episode is brought to you by the Advanced Textiles Products Division of IFAI. The goal of this podcast is to get to know the wide variety of positions and markets that make the advanced textiles world turn. We will be talking to professionals in different roles throughout this series to help inspire the next generation of textile professionals and anyone else interested in learning about others' journeys in the world of textiles. In addition, we would like to remind you that IFAI offers advanced textiles content throughout the year, including the upcoming Smart Fabric Summit, an event where government, industry, and academia meet for this year's theme, Disruption, Innovation, and Getting Back to the Future, happening March 28th through 29th, 2022 at North Carolina State University in Raleigh, North Carolina. Visit www.smartfabricsummit.com to learn more. Today's podcast showcases an interview by Mary Koutras, a Research and Development Manager of Duralast. Mary has worked with Duralast for 10 years and has more than 20 years of R&D experience. And now, let's talk textiles.
Welcome everyone to IFAI Talking Textiles. I'm Mary Koutras, member of the ATP Advisory Board, and I'm your host for today's Advanced Textile Products Division discussion. Thank you to everyone listening in on today's episode. Today, we are interviewing Thad Ribner, a senior engineer in the Research and Development Division of HDT Global. HDT Global delivers innovative solutions to military, government, industrial, and commercial market customers around the world. Thad, welcome to the IFAI Talking Textiles podcast.
Thank you. Good to be here.
Great. I'd like to start off our conversation by first asking about your educational path that took you to where you are today.
So my educational path, I did a bachelor's as well as a master's in what they offered as a 5-year BSMS program at Worcester Polytechnic Institute in Worcester, Massachusetts. So that while I was finishing up my 4th year of work for my undergraduate, I was able to, at the same time before I'd actually gotten my degree, start work on my master's program. And they even let 3 of the classes count for both. So that would be my my educational part of how I got to where I am.
Why did you choose to go into your field, and how did you decide while you were taking your bachelor's to move on to getting your master's right away?
In all honesty, it's a funny story, I think, a little bit. I don't know if anybody remembers My Side of the Mountain, but in either that one or one of the sequels, the kid who's traveling and makes his home on the mountain, he builds a whole bunch of different contraptions, such as a water wheel. And I think that's really what got me interested in all of these things that you could design and make just with what you knew how to do. I think that's what started me early on wanting to be a mechanical engineer. I actually knew what I wanted to do before I knew what a mechanical engineer was. Really, when I decided that I wanted to get my master's, I think that was actually while I was taking my bachelor's degree. I looked around at the environment at the time, the different jobs that were available. And, I looked at starting salaries a little bit, but really what came into it was the jobs that seemed of interest to me were those that required a master's degree. And so that's what got me interested in doing my master's degree. And as long as my university had the ability for me to do that a little bit more quickly, it just made sense for me to stay there and do it all at once.
What about internships or any sort of engagements while you were in school that helped, confirm that what you were going into is really what you wanted to do?
Well, at WPI, Worcester Polytechnic Institute, they have different projects that you're required to do in order to graduate. They're called the Sufficiency, the IQP, and the MQP. IQP stands for Interdisciplinary Qualifying Project, and the MQP stands for Major Qualifying Project. So essentially, the way it's supposed to work is that your sufficiency is not hard sciences based. It's, for lack of a better word, liberal arts, humanities based. The IQP is interdisciplinary. And so you're mixing in humanities with the harder sciences, such as physics or engineering or chemistry, whatever your interest is. But the thing about the IQP is that it's supposed to better the world in some way. Maybe you are in Namibia creating water distillers in order to help out the community have fresh water. And the MQP is completely in your degree so that you can really get a feel for what you're going to be doing in the real world, or at least one aspect of what you could be doing in the working world. And as I went through each of those projects, as well as through my classes to an extent, it really did confirm that I was on the path that I wanted to be on, that the things that I was doing were what I was hoping they would be. I'm not going to say that everything during college was easy. There was certainly a lot of stress. However, I saw where it was going, and it did confirm for me each step of the way that this was the path that I had designed to take.
Can you talk about any of the projects that you worked on?
Sure. So I suppose the most applicable one here would be my major qualifying project. And that was designing a lifting system for a woman with muscular dystrophy. And what muscular dystrophy is, briefly, is a degenerative disease that starts at the core and works its way outward to the extremities, so that you lose your ability to sit up, and then you lose your ability to, well, first you lose your ability to walk, because that's a core muscle as well, but then you lose your ability to sit up, and then it's tougher and tougher to move your arms, and then less to go is usually the fingers and toes and such. And the system that I helped develop was a system that was put in her bedroom so that she would actually be lifted from a laying down prone position with a set of slings that she was able to use still at the time, and was projected to be able to use for yet a while, so that she would be able to be lifted up in her bedroom into a sitting position, then placed down into her wheelchair so that she could go about her day. And when she was done with her day or wanted to take a nap, she would go back into this spot, and the lift system she could put back around her again, and she would be lifted up. And when she was placed down on her bed, she would be put down in a laying position again. She did have the ability to roll slightly while on the bed, which made things a lot easier. And she still had the ability to fasten straps. So it was a math problem as well as physics in order to get all of those straps and linkages correctly, so that she would be in a controlled position from the time that she put them on from a prone position until she was in a sitting position and back again. A lot of that also clearly included mechanical engineering in terms of the drive for the motors and lifts and such. But that was my major qualifying project.
Wow, that's really impressive. I mean, you mentioned that this program focused on, changing something for the good of humanity. And I can't even imagine the independence that you created for one person, and to give, that person that might have to depend on someone, give her the autonomy to do it herself. That's really amazing, Thad. And what an accomplishment. Like I said, I'm so impressed that you could help make a difference for one person.
Thank you. It was enjoyable to have that. I mean, there were certainly a number of other programs out there. That's the one that I chose. There's a matching program that the professors may already have an idea of what they want to do. Maybe they've been approached by somebody in the community, or maybe they've come up with their own idea. But alternatively, if you want to do an MQP that isn't on that list, you can approach a professor you worked with before, or someone who you think might have the same interest. And as long as you can convince the professors to get on board with what you are interested in, you have that ability to do so as well.
Dad, how long have you worked in your current industry?
Well, I graduated with my master's in 2008 and worked at a small company on the eastern shore of Maryland in unmanned underwater vehicles. And it's now 2022. And there have been a few months in between there where I was in between jobs. But I'd say that it's been pretty consistent since then. So 2022 minus 2008 is 14 years.
So you mentioned that you've had a couple of different job opportunities and work experiences. Have you noticed from going from one job and having different projects, has there been a progression or something that is steering you in one direction over another? Like one industry, one application is definitely has more interest for you as you've been, experiencing all of these different types of opportunities.
I like to problem solve. So a few of the things that I've worked on have been unmanned underwater vehicles, space inflatables, self-healing fabrics, self-rigidizing fabrics. I've designed expeditionary shelters. It's, they don't really seem like they all have that much in common. However, it's the thing they do have in common is the problem solving. I like to have a puzzle that I'm working towards.
It sounds like you've definitely even had a couple of positions that are, with the textile industry, and since that is, our focal group, I think that I was just wondering if there was, as you were exploring it, how did you progress towards textiles? So I see that it's part of, problem solving, and I think that that's definitely important for a lot of people that are listening and trying to decide what they want to do with their future. Is a lot of science and STEM type opportunities. There's so much problem solving that's involved, and to have that inquisitive nature and want to solve the puzzle, I think that's probably in our backbone, and why we partly choose what we decide to go into is because of that intrigue and trying to solve a problem. How did you get into then your current role, and can you talk about what you do as a senior engineer for HTT?
I was hired on to be part of the framed shelter design team at HTT. And basically that works with a series of linkages that move back and forward in a predictable way. And part of a shelter system is having, well, in this case, is having fabric on the inside and outside. There are several rigid shelters which do not require linkages and such. They maybe just slide open like the side of a camper. But when you're involving expeditionary systems, you want to pack things down as tightly as possible and get as much bang for your buck as possible. So when this shelter collapses down, the way to collapse something as much as possible currently is a framed shelter with a skin on the outside and a liner on the inside, allowing you to have an air gap in between the two, creates more insulation value. So when I started getting into designing the shelters, as I said, skin is the fabric, both the inner and outer are part of it. And you're always looking to have something stronger, lighter, of course, cheaper, but that's not always the option that you go with. And that has led me to different types of fabrics, such as nonwovens, that don't necessarily follow the typical structure that you think of as a fabric. I've looked at different energy saving methods that can go into fabrics, such as phase change materials being embedded in the fabric itself. Let's see, near field communications, such as having a magnetic film on the shelter, which allows you to not have to carry wires along with you. You can pass information along this magnetic field, potentially also power. And the phase change materials, to go back to that, that allows you, the more energy efficient your shelter is, whether it's from insulative coating or reflective coating or a phase change material, it allows you to have either no or a smaller environmental control unit, such as an air conditioner or a heater. And the less that you have to bring with you, or either you can get rid of it altogether depending on the climate you're going into, or if you can at least get it smaller or use less fuel, then that's less that you have to bring along. And when we're dealing with hospitals, mobile hospitals and mobile military bases, you wouldn't think that, a pound here or there makes a difference, but it really does, because you're multiplying that across however many buildings you're supporting, and all of the fuel that has to be transported also has to have fuel in the vehicles that's moving that fuel as well. And it just, for every bit of weight that you can save, you're really saving a lot of money in the long run, even if that costs a little bit more in the short term for the initial purchase. And so I guess you can see where all of the fabric development really comes into shelter design. But there are a number of different things that you can do with shelters, skins, such as being radar scattering, radar transparent, electromagnetic interference shielding and scattering, all depending on what you need to do where.
So when you have a project as like the one you were talking about, where you're looking into phase change materials or nanomaterials or magnetic technology, reflective coatings, what is your thought process as you get asked to work on a project, and you get some specific objectives that the material and criteria that it has to meet? What is your thought process, and how do you know, how do you find out what the newest type of technology is out there? Because you're not creating that technology, right?
We do not create the technology. We work with others. We do not create our own fabrics. We work with fabric vendors. To be honest, I've done quite a bit of background research, spent many, many hours on investigating whether something is out there, but really most of the innovation, finding out about a new product, probably most of the time, even before we know that we have a need, because there are solutions that we don't think there's solutions that we don't think are out there. We may have a problem with it, may think we've addressed it, such as, you want to heat or cool a shelter, bring a heater or an air conditioner. We might not know about phase change materials. Those, for example, and being embedded in fabrics, I found out at an IFAI show a few years ago back in Charlotte. That's really where, between that and a couple of different ASME and such places online, IFAI is really has been the go-to to find what's the latest and greatest in the industry. And sometimes you've got a problem and you have to solve it, but knowing what even is possible, it really relies on being able to find it. And my biggest source of finding the new information has been through IFAI.
I agree with you that engagement and networking especially with industrial committees, is so important as a professional. There are so many different ways to connect with people. As you said, with IFAI, even digging further down, such as ATP and ASTM, and there's so many committees out there, and it's been valuable for me to have this network of other companies so that when you have a project, you can build relationships and work with other people to bring technology that you don't create, you don't know that's out there, and hearing words of advice or hearing about the newest technology it's really eye-opening for me as a professional as well. You don't realize the impact of having these relationships and the networking opportunities and the involvement and engagement in committees. Just it's really important, and it's been important for me as well.
For sure. A lot of times we don't even have any design to use something new. However, when I hear about something new, again, usually through IFAI, occasionally other places, I do have a news feed that I've set up that I subscribe to, but usually it's through IFAI. When I hear something that could in some way benefit a mobile base, whether it's hospital or military, that's usually where I start talking to a couple of my vice presidents here and seeing if there might be a future in some sort of partnership, or perhaps just purchasing a new product from a new vendor. But a lot of the times the solution precedes the problem, if you will. You don't necessarily have a problem that you're solving, but you see something that's great that you want to create a new product from. That happens a lot too.
I agree. I think it's unique in research and development because we most likely have to work cross-functionally, right? There's a couple different ways that we get projects. One of them is, like you've mentioned, purchasing and looking at, new raw materials that they might come across. And then you typically have your sales department. They are typically the voice of the customer, right? So they have contact with the customers. The customer's like, hey, I have a problem. Sales comes to you and say, solve it. But then there's our own individual projects. And like you said, you go sit through a convention and you listen about new details. And you're right. You might not be aware of the problem, but if you can make a product and see if it will solve a problem, I mean, that's part of the way that, we scope our projects as well. Is we might not hear about the problem, but we see something that we know will solve a problem out there that someone's not talking about. In your current role, what would you say is a typical day?
It really depends on what I'm working on. The past couple of months, I have been mainly a test engineer for HDT's Wolf. It's a 6 powered wheel vehicle. It's they call it an electric mule or autonomous mule, but essentially it is a battery powered platform on which you can put equipment, or you can put litters on it to pick up people from a field. You can put autonomous unmanned vehicles, aerial vehicles on top of it to extend its range. And my job recently has been to test its output and capabilities. And that's where my day has pretty much been for the past couple of months, testing out different features such as power output and seeing what we can actually sustain. Because it does have a small generator, which is only used to recharge its batteries. But batteries can only give off or take in power for so long before they start getting hotter than ideal. And so part of what I've been working on is seeing under what conditions we can put out what amount of power before things get hotter than ideal. And then if it's hotter than ideal, how long can we do that for, et cetera. But I've also done some fabric testing with a tensile machine. Some people might be familiar with the trade name Instron, which essentially expands and contracts something between two manipulators, whether they grab onto a piece of fabric and pull, or they crush against something that you want to see its crushing force. I've been doing a lot of that recently for different arms of my of HDT. And I've also been doing some fabric flammability tests to 6413. So really the past few months, I've been almost completely a test engineer. Looking forward, we've got some products that need further designing. So I'm going to be working on that, as well as doing some drawings to try to get some things prototyped and then eventually produced. Previous tasks that I've had here were designing shelter systems, new linkage systems to make things, again, faster, easier, smaller, lighter, while expanding to a bigger footprint. Really depends on what is needed, what programs we have, and what's newly been discovered.
So you mentioned physical property testing for characteristics of the textile or whatever product that you're using, and that's using an Instron or some. Typically, they have industry standardized testing for those. Have you ever had to create a test method for how it would actually work in the real world?
I have. The most recent I can think of was to test the energy efficiency of a complete shelter system, because there are different properties that go into making a shelter more energy efficient, such as reflectance helps with getting rid of infrared heat transfer, thermal radiation. So we created several different types of liners that we wanted to use inside of a shelter. We had 4 different shelters set up. I created a test program so that I could see, for that time of year, how the shadows were going to fall, so that each shelter would get the same solar loading. It wouldn't be providing an unfair shade advantage to another shelter from its shadow, and figured out how everything was going to be powered in terms of heating and cooling, and how all of the put in 16 different thermocouple channels per shelter to see how these different materials, which in theory should have different energy efficiency characteristics, how they worked in reality. And I actually found myself to be quite surprised by some of the results, that what I thought was going to be a clear winner wasn't necessarily. Luckily, what I thought was going to be the best was the best, and what I thought was going to be the worst was the worst. But inside of that, things did surprise me a little bit. In the real world, things can be a little bit different than what the math suggests they will be.
Yeah, definitely. You mentioned being surprised by the results and sometimes not getting a result that you expect. How do you handle those times when you might get some disappointing results?
The goal is always to get better, but anytime you do research and development, you're going to have to, it's research and development. Sorry to repeat myself like that, but you're going to find test results that are positive and some that are negative. It just means you keep working on the problem. I had a color film for one type of material that I was trying to develop, and it was nothing other than the outer color of the material. And the tan color did absolutely fine. And then the black color went up in a conflagration when I did the flame test. Again, surprising, didn't initially have any thought that the color would be different. Clearly it was something in the dye and the ink that wasn't even thought of, that wasn't supposed to be flammable, but clearly ended up being flammable. And when you run into those things, you make a note of it, what worked, what didn't work, and you try to go from there to get to the end product that you're looking for. If something doesn't work, keep trying, or maybe sometimes the program runs out of money, in which case you say, well, this didn't work. But actually, sometimes that does happen with the complete program. You are trying to solve a new problem, and you go through all of the different research and you see the most likely way of solving the problem. And once you get into it, you find that you really can't. There are some problems that can't be solved with the type of device or method that people necessarily want to use, and you have to go about a different way of doing it.
I think that's really good advice and a good reminder for those that want to take that research and development track, that you don't always get the result that you want. And sometimes you have to go back to the drawing board. And at times that can be a little bit frustrating, but that's again why we're in this role. We're in this role because we like to problem solve, and you have to have the stomach to keep moving on. You can't take failure, a failure as, personal, and think that, you didn't choose the right profession based on one failure. And it's, you have to keep going. And I think that's a great, your story is definitely a great reminder of that for those that are interested in what we do.
If we already knew what the answer was going to be, we wouldn't bother with the test.
Would we even have jobs?
Right.
The one thing I've noticed that about our conversation, and I think, based on your path from academia to where you're at now, you care about helping people. I mean, look at all of the work that you're doing with sustainability. I would say that your projects that you've talked about they have to do with making, a better environment for the future, not relying on energy or trying to use sustainable energy, trying to look for ways to use less consumption, which is, that humankind, that element. And I see this trend of you just continuing to want to somehow make something better for the world or for people. And I think that's, whether intentional or not, I think it's really admirable. And I'm kind of excited to see where when you get to your next point, what does that take you? Because I keep seeing you in this path.
I certainly like to solve a puzzle. I don't think I ever thought of myself as a humanitarian or something like that, but thank you.
No problem. What about inspiration? Have you had inspiration or mentors from, either in school or, and through work and where you're at now that you lean on?
I've certainly gone to different, in college, I certainly went to different professors to discuss things that weren't necessarily, say, homework related. And I certainly enjoyed several of the conversations I had with some of them. But I can't think of at the moment any mentors per se. Certainly everybody has their own specialty, and I have on occasion gone to one of my other coworkers who might be slightly better at electromagnetic interference than I am, or maybe I'm working on a particularly difficult controls problem. I'll probably go to somebody else to ask their input on it. And I'm certainly not a programmer. There are all sorts of different specialties and abilities that just because somebody maybe they're just starting their engineering degree, but they might be really good at something that I might not have used for a while, or it might not have ever held interest for me, or I might not have been good at it. And luckily we are a team, and I'm able to go to other people, even a couple of friends from, personal life or school who don't necessarily work at this company. And on rare occasion, I'll go and ask them, if their input or their thoughts about how I might approach something. But one person cannot be an expert in everything. So yeah, I do go to speak with other people, usually in my company when it happens, and just different areas where I'm not the best at, whatever the specific task is, I need their skill set.
And I think that, again, when there's mentoring and there's mentorships, there's people that you work with that you can lean on and collaborate with. But again, having those industrial committees that you're a part of, because that's another resource for you that you can, ask some questions about and get some feedback, because you are right. There is not one person that knows everything. And nor know it well, right? So as you are in your career and you have experiences, you learn, what you may be better at over something else, especially even within your own degree. I know that I'll never be a programmer. That will never be my that won't be my thing. But in terms of problem solving, I can do that well. I know who to go to. And I think that's important, that you know who to go to as you start in your career and you have exposure and you start meeting people. You start knowing who is the expert, who's going to be able to help you, and developing those relationships is really important, especially as you're starting to come into, your professional career and what you want to do.
Indeed.
Can you highlight some of your greatest achievements?
Sure. Let's see. I guess the one that stands out for me is a couple of years ago, I developed a new method of articulating our frame shelter, matching. I mean, it doesn't really make sense without seeing pictures, but matching dissimilar lengths of a 4-bar mechanism, essentially, that allows for extended sections of the shelter. I was able to get a patent for that, something that people had previously said was impossible. So, I mean, that felt pretty good. I've worked with different companies to develop, again, the lighter, stronger fabrics, the more energy efficient fabrics. And it's really nice when something pays off. But I mean, on the other hand, I have had setbacks, such as when I design a new shelter and everything looks good on paper, and then when you put it up, it doesn't actually bear snow load like it's supposed to. And, you do your best to put additional changes on that and fix it, maybe put some more snow load cables on it, but then it collapses and you do have to go back to the drawing board at some point.
That's where being resilient is so important. What kind of advice do you have for, students that may just be starting their college career and maybe thinking about going into STEM, but they're not really sure?
Okay. If they're starting their college career and thinking about going into STEM, if they haven't already entered college, I would suggest they look into what the different intro classes look like. See if any of those hold any interest. Don't necessarily solve the problems that are in them, but start, research it online, maybe see a couple of free example problems or lectures where you see how things are talked about, see if it holds interest for you. If you're lucky enough to be able to go and speak to faculty, either at the high school, maybe there's a technical aspect in the high school, or perhaps a visit to the local community college or state school. Often you'll find professors are happy to speak with you if you don't really know what you're going to be doing already. Learning more about it, I guess, would be my best suggestion. Once you've selected your college, to start anyway, you can certainly change colleges later. That's not uncommon. If you find you want to be doing something else than what you're currently doing, you can transfer credits and go somewhere that fits you better. Maybe you started with an English major and you want to be a civil engineer, or maybe you started as a programmer and you want to be an art major. That's certainly been done. But the only way you're going to find out if you have an aptitude for it or if you really enjoy it is if you try to experience those things, see what they're like. It's the only way to see if you're going to enjoy them or be good at them.
Yeah, I think that's great advice. The one thing that I would add is, I know a lot of universities and colleges have career services, or they'll have internships, and going to your career services to see what positions might be out there as an intern or co-op. I know that really helped me affirm what I wanted to do. I know we have some local universities that have internship programs. So I agree with what you said. And then, having that experience in the hands-on, that will definitely help you make sure that you're, going into the right profession for you. Thad, I appreciate everything that you've said and all of your comments and our discussion. I applaud you and all of your work. It's really interesting to hear from an additional peer and colleague about what their experiences have been and your accomplishments. I think it's refreshing to hear different perspectives, and kudos to everything that you've done. I've enjoyed this, and thank you so much for teaching all of us about your path and giving us advice for those that are potentially college bound or looking into different types of careers that are out there. Thank you so much for your time.
It's been a pleasure.
Thank you for joining us for this episode of IFAI Talking Textiles, brought to you by the Advanced Textiles Products Division of IFAI. IFAI is a not-for-profit association representing the international specialty fabrics marketplace. Learn more about events, workshops, and webinars IFAI hosts throughout the year at ifai.com/events.